In this chapter, we are going to talk about MDX queries. And part of this specific chapter, first, I'd like you to understand MDX query statements, and then I show you how to create a simple query. First of all, let's compare MDX expressions versus MDX queries. And then, of course, as I mentioned earlier, you have to consider either you're dealing with a single value or multiple value. We also talked about tuple before, and now we are using tuples and we are using set commands in here. And finally, we are going to learn when do we need MDX queries versus MDX expressions. And of course, we have some demonstrations in which help you to understand the subject matter a little bit better. And then I also introduce some of the new terms. Part of the MDX topic and technologies that is available, you have to consider that you can use MDX in two different ways. We have been dealing with MDX expressions so far, and we could use the MDX expressions within the calculated member. MDX expressions basically is nothing but a multidimensional formula, very similar to the spreadsheet formula. And MDX query statement, what it does is very similar to SQL query and uses the expression in there. As a matter of fact, some of the keywords are exactly the same, like select, for example. So why do we need the query statement? Because you would like to create custom solutions. Like, for example, you want to go and create your own client application that accesses your cube information. You need a statement for that. Expression alone can be used within a calculated member. However, if you want to have it programmatically to be retrieving a result for you, then you need to have a statement. If you wanted to compare the values that you're getting, either you're dealing with multiple values or you're dealing with single value. In either case, you either deal with aggregated values or discrete values. Discrete value refers to a specific location in your cube. We talked about the concept of tuple before. And if you remember, tuple was nothing but intersection of many different dimensions that you were setting. By default, if you just go with the tuple and the measure name, or for example, whatever the fact table measure is, you get the whole result of the entire cube. However, if you put the intersection by separating the dimension with a with a comma within the parentheses, then you were actually pointing to a specific location in your cube. The beauty of discrete values is that you could combine multiple tuples together and get the final result that way. Very, very similar to the nested queries in SQL Server. Versus aggregated values, which would have given you a summary of a certain specific section of your cube. So, as far as the value goes, the single value needed by the calculated member could have gotten from aggregated values. Now, the function of an MDX query statement is to get the data in a specific location. So if you take a look at the cube, basically a cube could consist of up to 128 dimensions, as you know, in SQL Server Analysis Services version 2000 Enterprise Edition. And as you know, the cube is symmetrical. That means every single dimension intersects with another dimension, and that creates a cell for you. So each cell has a location, as we talked about it before in chapter 4. Now, you have to consider that by the time you're populating or processing the cube, you're basically finding the answer for every single one of these cells in here. So the cube itself has probably up to 128 dimensions if you have Enterprise Edition. If you have SQL 7.0, you could have up to 64 dimensions. 2000 has extended that. And as I mentioned, it's symmetrical. That means you have to find the intersection of each available dimensions. Remember that by the time you're processing it, you would have calculated the aggregated function on every single intersection. In other words, here you had one value, you had one value in here, and you had one value in here. So every single cell will have been calculated in this scenario. As far as the report goes, by the time you want to get the information from multiple dimensions, it's very difficult to visual that, obviously, in computer, specifically if you have more than 3 dimensions. You can't really come up with any other technique rather than a pivot table in here. So if you look at the report basically doesn't have any dimension. The way that you're showing it is by showing different columns and different rows and comparing the values against it. So if you take a look at it, since report it will be displayed on a monitor or a printer, has only 2 dimensions, very similar to the table. and is asymmetrical. That means not necessarily you get the intersection of all dimensions at the same time. You only see the intersection of two dimensions at a time. And then of course display a subset of a value from the cube. Not necessarily you see the entire value of the cube. So if you understand this specific topic in here, then you understand that how do we get the report from a cube by using the query, and we call those an MDX query. I have a demonstration in here that I'd like to show you. In order to do this, let's go in here to Analysis Manager again. I'd like to show a single cell with a default tuple. So in this scenario, what I'd like to do, I'd like to also navigate to Module 5, and there is a specific HTML file in here. If I open it with the Internet Explorer, as you see, I automatically get the total value of my cube. So the cells unit of the entire cube is 35,696. This is actually the tuple, the default tuple that gets me the result of the entire cube. That means that's an aggregated value for all available dimensions, and that would be the calculated value for it. For example, if you have, let's say, employee, product, state, time calendar, and physical, the combination of all these means all employees for all product, for all state, at all time, we have sold 35,696. Now, in order to show basically a specific single cell with a specific tuple, not the entire default tuple, like not the value of the entire cube, then we need to go actually and basically drag some of these dimensions into our pivot table, and then we can see a specific cell in here. So as you see, this is a grand total. If you add these three values, you get 35,696. If you want to, you can also break it down by employees, for example. Now in this scenario, if I wanted to break it down by a specific user in this scenario and a specific category, you can even break it down in more units. So in this demonstration, you see that every single cell represents a specific tuple, and then the grand total all the time is basically referring to the default tuple, which gets the value of the cube. So if you add all these values together, basically these three and also all these rows, you get 35,696 anyways. So you can actually take a total in here. If you add all these specific columns, 264, 299, 334, and keep going, you get actually 35,000. Or even you add the columns, you get the same thing. Very similar to the spreadsheet data. Now, if I go and get rid of, for example, my employees, get it out of my basically list in here, and let's go with the product category and bring it over here on the row, and then I like to go and, for example, add the time calendar in here. You can actually break it down by time. If I also add the time physical, as you see, I can't add it to the columns anymore because I already have a time, one dimension on the column. I have to actually add it part of basically the a specific row in here. But as you see, the time physical and time calendar cannot be shown at the same time because they are the dimension hierarchy. You can have one over the other. You can have both because they are referring to the same dimensions anyways. However, you look at it differently. So that's another characteristic of hierarchical dimensions. You can't have more than one at the same time on the same level. So either you can see the calendar or you can see the physical. You can't actually see both and compare them that way because it just doesn't make sense. So keep that in mind, that some of these dimensions that we are making is just for ease of usability of our product. Not necessarily we can just apply these two dimensions part of the same pivot table. You could also assign security differently for them. You could actually customize it differently. You could hide and show some of the levels differently. But you're looking at the same exact dimension table. So that's the way that you're changing it. You could consider it like a view in relational database management system. You're looking at it in a different way. That's the only thing. But you're referring to the same exact thing. So because the time physical and time calendar are hierarchy of the same dimension, you can include only one at the report at the same time. You can actually have more than one. Now, as far as the placing these dimensions on the axis, as you remembered, I mentioned that you have rows versus columns. You could actually drag and drop some of these dimensions onto a row or columns, basically. They call these axes. So the axes here allow you to basically control the data the way you like to present it in here. Also, we have the expandability. As you see, you can expand it, drill it down, or drill it up. And as you see, the pivot table gives you the capability to highlight. It shows you exactly which specific location you're looking at. And pay attention to this one. If I select one specific column in here or row in here, automatically shows all related values for that particular category. If I click on July, for example, it shows both rows. If I select 1998, it shows the whole thing. So it really depends which one you're looking at, and then you can make a basically a smart allocation, and you could find out exactly which section of the value you're looking at. For example, here you're only looking at the frozen chicken, and that section would be appeared in here. So the color coding helps us in order to understand exactly what area you're trying to manipulate. You could put two dimensions on a single axis. You could actually remove individual members from an axis. As I mentioned, you could select basically a particular dimension, and as you see here, you could specify which one you don't want and filter them out, slice it and dice it that way. So that gives you lots of flexibility in there. So as far as like working with this pivot table, it really depends on your preferences, how you want to apply these dimensions into either rows or columns. Again, programmatically, you could manipulate whatever you see here graphically using the query statements. So if you wanted to have like a persistence value, if you want to show a default value somewhere, for example, you want to expand a few dimensions here and a few dimensions over there and see the intersection, you have the query statements for it that programmatically could show a value. Not to mention that this is an ActiveX control. This is a web control for Office Pivot Table. If you want to, you could create your own web-based solution or window-based solution and have the user to choose either like a combo box or a list box or perhaps an English queries statement, and then based on those information that you get from the end user, you could actually build your MDX query statement and then show the actual result that way. So as a summary, each position basically consists of a tuple. This is a tuple, this is a tuple, this is a tuple, and so forth. Every single section is a tuple, no matter how down or how up you go into see specific data. Every single cell represents a tuple value, so keep that in mind. The rows and column axes can contain a set or a set of tuple. What do we mean by that? If you think about it, let me get rid of this field list. And by the way, let me refresh this a little bit. Now, check this out. Here at the moment I have a grand total, and as you see here for December, month of December, I have 837 for the country of USA, right, for the quarter 4th of 1998. This is a tuple. However, quarter 4 consists of a set of tuple. If you think about it, every single cell is a tuple, but quarter 4 is a set of available tuple. So you're actually creating a collection of available tuples and make it as one single entity. 1998 is a set of sets. So as you see, a set could consist of one or more tuple, and then you could have a set of sets which consists of more tuples. This color coding extremely helps me in order to show you and demonstrate what do I mean by set, what do I mean by tuple, and how do you group them together. So basically, you could consider the year, which consists of sets of tuples. So that's the way we are dealing with basically information here, part of MDX query. Let's go back in here and let's talk about the subject matter again. So as I explained earlier, the whole idea of this particular chapter is to show you how to design MDX queries. So obviously, in order to deal with MDX, you have to use a tool, such as reporting. One of the standard tools that Microsoft gives you is a pivot table. Of course, there are third-party tools that might do a better job. There are some tools that not only allow you to graphically create your MDX queries, but also they allow you to show and view it. I'll demonstrate a few of them here for you, and basically one of them is already been given to you by Microsoft, as a matter of fact, and you do have it part of your student material as well. So let's talk about some of the terms again. Access is defining the row and a column heading of a report. And basically the row and a column heading indicates how do you want to look at a specific dimension. Now the set, as I mentioned earlier, is a multiple member on an axis. Like for example, if you want to look at the time, each year is a set of quarters, and each quarter is a set of months, and each month is a set of values. So depends upon what other intersection of other dimensions you're looking at. So you have a slicer which allows you to filter a specification for a report, like you could hide or show a particular level. And then you have the tuple, which we talked about in chapter 4, one member for each dimension defined by a slicer specification and a row column set, which specifies exact coordination of that cell, like a spreadsheet, for example. You get A23, for example. You go to the 23rd row and the first column. Here in cube is no difference. You go with dimension A, dimension B, dimension C, and then you get the intersection right there. That's the tuple. And then you could combine the tuples, that makes it a set. And then you could create a set of sets, and create a set of sets. You could keep going and really looking at it in a different way. So you go back all the time to a member. You always want to look at a particular member. So a member is a single item for a dimension. So the way that you're looking at, you know, a query statement, we are dealing with this specific terminologies all the time. You're dealing with an axis. Where do you want to show the data? Rows or columns? Because remember that MDX always and always return the multidimensional values into two dimensions. So you got X versus, you know, Y's, or perhaps rows versus columns. So where do you like to place the information? Where do you like to show it, for example? And then the set, which is a set of value, a slicer allows you to filter it, tuple, it shows a specific value, and then the member allows you to do the filtering really. You do the slicing based on a member, obviously. I have a bunch of demonstrations that really get into the activity in here. In the first demonstration, I'd like to introduce a third-party application that Microsoft has provided part of analysis services, and also you do have it part of your student CD, just in case. And then I'd like to show you how to create simple MDX query statement. And then we're going to review some of the functions that we have already talked about, part of previous chapters, such as level members. If you remember, it would have referred to a particular level on a particular dimension. And also you have set with explicit member. You could actually go and create your own set if you want. Not necessarily use a tuple, but you could create your own set. And then we're going to learn the difference between a set and axis, and of course specifying what set goes onto what axis. Like for example, are you going to place it on a row or on the column, and so forth. And then we're going to go and learn the simplest possible query, and sometimes you want to go and put condition, criteria, put a filter. Anytime you do filtering, you actually go with the where clause. Very, very similar to the select statement. And then we're going to go and learn how to do query with axis. So let's first start learning the tool. In order to understand the tool, the first thing we do is getting to know a particular tool that is available in here, part of SQL Server Analysis Services. You have the MDX sample application. Microsoft gives you that. This MDX sample application basically opens up a tool that allows you to connect to an analysis server. As you see, this tool graphically allows you to create MDX queries. This tool is pretty good. However, part of the lab environment also, Microsoft provides basically another tool in here. They call it MDX 2093A. This is exactly like that tool that comes by default with analysis services, but has some templates that Microsoft has created for you. So it's a little bit more modern in comparison with the original one. You see, it asks you, would you like to save your queries? It gives you the parsing, syntax checking, and so forth. This tool can be used basically by your own internal used in company. So you could take advantage of it. Part of this class, you get the tool anyways. And doesn't need to have any setup or anything like that. It's just an executable. It's a very small little file. So if I connect to it, as you see, I just don't want to have any file to be created just yet. As you see, part of queries, you got some templates in here. Maybe you don't want to have an axis. Maybe you want to have only columns. You don't want to have a row. Maybe you want to have both rows and columns. Maybe you want to add a where clause. Maybe you want to have a with member clause. in this chapter, I'd like to show you all this information here for you. So right now, by default, Microsoft has connected to FoodMart 2000, and of course these are the cubes available. You could actually connect to Market, and these are the cubes available for that. So as many as basically databases that you have, you can actually show them in here. That's the DB, and then these are all available cubes for that particular database. So if you wanted to take a look at this, you got the toolbar in here, which shows the databases. It shows actually the queries, just in case if you have already ran few queries. That's the last frequently used queries in here. You could actually see them, so you could jump around between different queries without retyping them again. So it actually creates a recently used queries for you. And then of course you have basically delete the query, you can clean it up, you can create a brand new query in here. You could actually take a look at different views in here. You don't want to show, for example, let's say you just want to see the query, you want to see the result, and here the split window. This is the result that you can see. It will show the result, but here that's the query that you only see in here, and then finally that's only the result view. So you can, this is the most complicated view that you have in here. It shows everything here for you. Remember that this specific application, MDX 2093A, will not allow you to save a query file until you have created at least one query. In other words, you can't just save this right now. You have to have something in there in order to be able to save it. Let's compare that with an existing MDX that comes with analysis services. So let's go in here. As you see, this is something that Microsoft automatically gives us. Very, very similar to that tool. However, you don't have templates. As you see, under queries, you don't have a template. So this is a specific modern tool that Microsoft has enhanced it only for people who are taking this specific class. So this section is very, very valuable, really. But if you don't want to have this, if you don't take this class, still if you learn the knowledge about MDX, you can still use the original tool that comes with analysis services. But since you're taking the training, Microsoft has done a good job, and they have given us some templates so we could take advantage of it. So keep that in mind. You got the query pane in here that you can actually put your information. Then you got the metadata. As you see, if I choose any cube, the metadata shows available dimensions for that cube, perhaps. Depending on the cube, you could see all available dimensions for it. You could actually see the levels in there. You got the function. So basically, not only you have a small mini engine of the calculated member builder, but also you have the query statement builder. So you can combine MDX expressions with MDX queries right in the same package. So this is a modern tool. But would you do that? Would you create a calculated member in here as well? It's not a good idea, because you could create a calculated member and refer to it while you're in here. So you could take advantage of it. Now, let me get into a small little demonstration here for you. Let's go and switch, for example, to a specific cube. Like, for example, if I go to Market and if I choose Sales, as you see, the first statement, very, very simple statement. What I like to do, say select, for example, from, I go with the cube name, Sales. If I execute this, automatically shows me the total value. So select from sales. That means just go get me the result in here. So this is basically the query, MDX query that searches the default tuple. That's what it does for me. Now, if I wanted to just basically start from scratch without knowing anything, I can actually go here on the query and say insert a template with no access. That means there is no row and there is no column. You see, automatically the template tells me what do I have to write. That's the good thing about templates. Select from cube, and the cube here could be, for example, sales. You see, the same capabilities that you had in calculated member by double clicking on an object and replace it with a token is available in here as well. So you could see that. So in this simplest possible MDX query, you're just basically getting the result of that, basically, let's say, cube. In order to add a comment, just for an info, what we have to do is very similar to the C++ statement. I can, for example, go ahead and put a comment in here by using the \\, and basically say this is a comment. And if I run this, again, it does work. If I don't do that, then you're going to have a problem in here. It says that, you know, this specific command, it's just not obvious. This is a command. You could also use the --, very similar to the ANSI in SQL Server, that you could go and comment it. You could also do the comment block. You see that right now? If I go say, this is the comment, it still works the same way. Or go with the \\, in here. actually // or you could just go basically with the C++ style, for example. You could do this way. You could do a comment blocking and have more line. Let's actually do this. I'll go with backslash and then actually, sorry, I have to put it in here. There you go. You could do the comment blocking. That actually goes as many as you want. In other words, you don't have to just type in anything you want. So there you go. I do the comment blocking in here, and it's still working the same way. So I showed you how to do the commenting part of the MDX query. You could use either // you could use --, or you could do comment blocking. So that's totally up to you how you want to go and do the commenting. Commenting is important because later on you can come back and see why you have done that, or what was the reason that you have used that specific command. Sometimes you want to use rows or columns labeling in here. We call them an axis. So in order to do that, we can go to insert a template. And as you see, the first simple one that you can go with is columns only. So as you see, automatically the template is going to show you the syntax. So you don't have to really memorize anything. That's a pretty cool tool. So select from a set. As you see, the set needs to be identified, and also the cube has to be identified as well. Let's first go with the cube because we're already familiar with. So I'm going to select from the cells, but we are going to place a set on the columns. What is it that I'm looking for? So as you see, if I select the set in here, I can actually go through the functionalities in here. And as you see, there is a category called set. I can take advantage of these functions in MDX. And let's go down in here. And basically, let's go with members, for example, level. As you see, I'm searching for members on a specific level to place on the column level. And instead of the level itself, I can actually go and bring it over from the categories, for example. So what I'm doing, I'm placing all the members on the product category on the columns. Let's go run that. There you have it. All the categories of the product dimension are being placed instead of my column heading. So that's pretty nice. You can actually create a column heading and separate the values in there. As you see, if I comment this, it actually gives me the entire tuple. If I don't comment it, it places all the categories of the product dimension right in here, part of my basically column heading. And I don't have any row. As you see, I only have a column. Now, you could save the query if you will. Let's go and save it. And of course, you could save it as a file name. For example, I call it column only and save that. Now, basically here now, I like to go and add two sets. So let's go get rid of this and insert rows and columns. So if I go with rows and columns, as you see here again, I need a cube. The same story is true. I have to specify two sets now. I put one set on the column, one set on the row. So in order to do that, I basically do the same thing for columns. I go with members level and I choose categories in there. And then on the row, I go again with members basically level and I put a state, for example. And I go country in there. So if I go run that, I actually show the categories on the column and compare it against different countries. So as you see, the templates are helping me in order to understand this in a better way. So consider that columns and rows are simply aliases for the true names of x's or x's. It's totally up to you how you want to look at it. Rows or columns versus x and y and so forth. So x is 0 versus x is 1. Whichever comes first. This is x is 0, this is x is 1. Or vice versa. It really doesn't matter. By the way, as you realize, we are separating the columns and the rows by using a comma in here. Can I just go ahead and do this in a different way? Like, for example, put the rows first and then columns. See what's going to happen. The same result. So it really doesn't matter the syntax and sequence of it. You could just do either or. It's just a matter of you're separating it with the comma and the row. Because this syntax is important. It tells you where you're placing them. Not necessarily which one comes first. But whichever comes first has to have the comma right after. So keep that in mind. Now, we talked about the set before. Let's go back in here. And let's just get rid of, go with the next new column query. By the way, as soon as I click on next query, then the first query is available right after that. You can actually save it or get it in a different way. If I go here and say instead, for example, this columns only, get it from the cube and then the set, and instead of going with members level, then I like to use the set function itself. In order to create a set, you have to use the braces in here. Within the braces, you can specify a set, like very similar to the tuple. But instead of having a particular tuple, I can make it even easier. I can go with measures and choose sales, for example, dollar in here. Let's actually drag and drop it over here. Oops. By the way, this is not a very perfect tool. Sometimes we have some glitches in there, so just bear with it. Double clicking, for example, wasn't available, as you see. You can drag and drop it though, right? So it's not the perfect tool, but it's better than nothing, as you see. So what I'm doing, I'm creating a set of these two specific units on columns. Let's go run this. So as you see, I'm putting the sales dollars and sales unit right on the column in there. So my set consists of these two values. That's a set that I made. Has nothing to do with any levels or any dimensions or anything like that. Actually, I am dealing with measures dimension at the moment. You could also combine tuple with a specific, for example, predefined set. You could make it very complicated if you want. But before I get into the detail of it, let's go and put conditions now. For example, in this scenario, I like to add a slicer specification in there. And like graphically that you could go and specify the slice, I like to go and do this graphically. Oops. Now, let's go and get rid of this and add a new template. And this time I like to go with the where clause. You see that? So the where clause basically just adds that into it. But beforehand, you have to have a query. Unfortunately, the where clause doesn't give you the whole thing. So let's go with the columns only. Once again, I'll go with the set functionality. I'll go with the dollar, comma, and go with the unit, and then close the braces in there. And as you see, it does work the same way. Now I like to add a where clause in there. And that will add it right at the bottom of it. Now the where is looking for a tuple. Based on what condition? So I can actually specify the condition and put the tuple sign, which is the parenthesis. The set sign is braces, but the tuple is parentheses. So part of the tuple itself, I like to go and look for product, basically bread, and I like to look for a specific time, like perhaps 1998. I like to show all the breads in 1998, see the sales dollars and sales unit for it. So as you see, the value has changed. I like to see how many units I have sold in 1998 for the category of bread. So look at this statement. This is not using MDX expression, it's using MDX query. So basically, you can eliminate lines of code in relational database management system. You don't have to write any joins or anything because everything has been calculated already. You get the result in the quickest possible way. So in this demonstration, what I've talked about, I've actually talked about the member level function in here. If you recall, part of the set we had members level function. We basically talked about how to work with different templates and so forth. Let's go save this and go back to our demonstration in there. I'll go with, for example, column only 2. And let's get rid of this. Switching back here to our PowerPoint presentation allows us to talk a little bit more about this particular chapter, chapter 5 of course 2093. So let's go review, see what we have talked about. Obviously, we talked about the terms, and I showed you a demonstration how to work with MDX 2093A application, and I showed you how to create a simple MDX query statement. Remember that I introduced level members function, returns a set of all members of a level. Was very equivalent of Office pivot table for placing a level, and you could use it within the metadata tree, like drag and dropping a particular level from the dimension area onto the query section. You could use it on a row or a column, it's totally up to you, and you could basically use it within a set group, if you remember. In this example, you're returning all members of the quarters level of the time. The reason they don't show the whole thing because perhaps they have only one time dimension. You have set command that you could specify explicit members, as you see, or you could basically combine them with different levels. As you see in this scenario, the braces can include sets. A set of sets is still a set, obviously. Look at this. You have a set of sets. This is one set right down in here. This is another set. Basically, your set at least has one member, right? And then you have a set of sets. But we didn't do that in here. We didn't put the braces in here because by default, one level, we're not going to consider as a set, but it is a set. In this scenario, you could combine this set with this set and go on with a bigger set. So sets and axes. Use a set to display multiple members on an axis. A set is a collection of one or more tuple. And the basic tuple was at least carrying one member, if you remember. And a set appears only on an axis, not in a where clause. Remember that. Set only appears on an axis, either row or column. On a where clause, you have to use tuple. You cannot use a set. This is very important for you to remember. And then each axis must include a set, obviously. If you are putting a row or a column, you have to have a set. You can't use a tuple. Well, by default, you could have a set that has a simple tuple in there. So you could keep that in mind. You cannot skip an axis. If you go with an axis, you could have a no axis, just get the pure command of the cube, if you remember. But if you are going with a row or a column, then you can skip the set, obviously. A dimension can appear once on an axis and where. In other words, you cannot put more than one dimension on the same axis. For example, if you have like 2 times, like time, calendar, and physical, you cannot place both of them on the same axis. So keep that in mind. Query statement may have up to 128 axes, very similar to the cube itself in analysis services. So the columns usually is axis 0 and rows are axis 1. So keep that in mind. The simplest possible query is select from sales. That gives you the complete result set or default tuple. You could put the where clause, as you remember, specify the condition, which definitely requires a tuple. You cannot use a set for where clause. And then queries with axis, you cannot skip an axis, but the order of an axis doesn't matter. If you remember, I replaced the rows and columns. But be careful, if you do that, then also put the comma right after the first axis. A dimension can appear only once on an axis or in a where clause, so keep that in mind. By going through all this demonstration, we get into a lab. In this lab, you're basically doing the same thing. You're going to create simple MDX query statements, and by going through that lab, you're basically done with this specific chapter.